everyone. Myself Radha. Today in our class we will discuss about classification of magnetic materials. Okay. In this we will discuss about classification of magnetic materials and types and their differences with examples. We will discuss in brief. Okay. First of all, classification of magnetic materials are mainly three types: diamagnetic, paramagnetic, and ferromagnetic. Okay. In diamagnetic examples are water, alcohol. In para, aluminium, chromium, lithium. In ferromagnetic there is a example is iron, cobalt, and nickel. Okay. First of all, what is diamagnetic? Any material that can be magnetized by an applied external magnetic force is called a diamagnetic. Okay. Any material that can be magnetized by an external magnetic field, okay, is called a diamagnetic materials. Example: iron, nickel, cobalt, which is iron, nickel, cobalt, which is widely used in different fields. Okay, these three types: iron, nickel, and cobalt. Based on, for example, first we will study. For example, in this, for example, iron and north and south, two poles is there. North and south, two poles is there. For example, north and south, two poles is there, and two poles is there, and one object, materials kept in between them. Then the lines of force, not allowed to go through the object. This is called as example is a diamagnetic material. In diamagnetic material, the lines of forces, these lines of forces not allowed to pass through an object. Okay, objects, the lines of forces do not allow to pass through an object is the example of a diamagnetic material. Okay. If a magnetic field, in a magnetic field, you can say if external magnetic field kept in this, any substance kept in this, what will happen? Two possibilities there. Two possibility will be happen. If we kept any substance in this, two possibility will be happen. What is the two possibility? Either lines of forces pass through it. Okay, either lines of forces attract. In this two possibility, lines of forces attract, or the lines of forces do not allow to pass through it. These are the two possibilities. Based on the magnetic field, it is classified that suppose north and south pole is there, and the lines of forces do not allow to pass through the substance. Okay, it's called based on the magnetic field is classified. Okay. North and south, for example, in between a north and south pole, we kept any magnetic material. We see what happened. Substance pushes. Okay, substance pushes, not allow to pass. Substance pushes material, not allowing lines of forces to come inside. Okay, this is the main point. Okay, you remember, lines of forces do not allow to come through the substance. Okay. We see that what have another main point is lines of forces goes outside. All you see in this, you all see lines of forces goes outside. Okay, not come inside from substance, goes outside. These type of materials is known as diamagnetic material. Okay. You understood now? If I am telling clearly, if two poles are there, north and south. Okay, in this once substance is kept in between north and south pole, what will happen? the lines of forces, see, the lines of forces not allow pass through the substance is called the if north and south pole is there, the lines of forces do not allow pass through the substance is called diamagnetic material. Okay, remember this. What is diamagnetic material? You understood. Okay, these materials which is kept in external magnetic field, the material do not allow lines of forces to come inside. Okay, goes outside. Do not allow to lines of force come inside. Okay, not allowed to come inside. They are going outside. Okay, not allowed to come inside. Okay. Rather we can say these push the magnetic field. Okay, these push the magnetic field. The material. So these type of materials are said to be diamagnetic material. Okay. Next we will discuss about para and ferromagnetic material. Okay. The basis we see para and diamagnetic material. There is a small difference is there. Okay. Para and ferromagnetic material, small difference is there. What is that small difference? We discuss. I will tell. We discuss what is para. First, what is paramagnetic material? These materials which is kept in magnetic field. Okay. For example, there is a north. See, there is a north pole and south pole. Okay. In which one substance is kept in between them, and the lines of forces allowed to pass through them is called paramagnetic material. Same paramagnetic material also same. That lines of forces pass through them is called ferromagnetic material. But in paramagnetic material, all the lines of forces pass through them. But in ferromagnetic material, few lines of forces allowed to pass through them is called ferromagnetic material. Okay. In this, first we have to discuss paramagnetic material. What is paramagnetic material? Those material which is kept in magnetic field. Okay, I just told you. Again I am remembering. Those magnetic if lines of if these lines of forces allowed to pass through this substance is called paramagnetic material. Okay, which is kept in a magnetic field. Diagram is shown this clearly. Okay. This material allows magnetic field to pass through it. Okay. In diamagnetic, the lines of forces do not allow to pass through the substance. In diamagnetic, in para and ferro, the lines of forces allowed to pass through the substance. Okay. Clearly you observe in the diagram. Pass through the substance is called paramagnetic material. If the lines of forces, all the lines of forces allowed to pass through it, you remember, listen carefully, is called paramagnetic. And what is ferromagnetic? Few lines of forces allowed to pass through the substance is called ferromagnetic. Okay. Next, those material are called. Next, main difference in this I will tell you. You see. These material allow magnetic field to pass through it, but those material are fably. Those material fably. Fably means weak. Okay, weak for magnetism. Okay, fably magnetism, weak for magnetism. Okay, those material allow magnetic field to pass through it, but those material are fably. Okay, fably means weak in magnetism. Fably means it is weak in magnetism, whereas ferro is strong in magnetism. Okay, whereas ferromagnetic material, they do not ferromagnetic material magnetic field pass through it. They also attract. Okay, in ferromagnetic material, but these in this magnetism are strong. Okay, in this magnetism are strong. In this strong magnetism. Next, if same in ferro also, all the lines of forces pass through it, passive is known as a paramagnetic material. Okay, and is known as a paramagnetic material. If few lines of forces pass through it, is known as ferromagnetic material. Okay. Next, the main difference of this is what is ferromagnetic material. Ferromagnetic material. What is ferromagnetic? Sorry, what is ferromagnetic material? Ferromagnetic material. Sorry. First, what is diamagnetic? Diamagnetic is a difference between the three. Diamagnetic, magnetic lines of forces. Magnetic lines of forces applied a magnetic field, which tends to avoid the diamagnetic material. That is, do not penetrate materials in diamagnetic. In which ferromagnetic material, what is the magnetic lines of forces is applied the magnetic field, but it tends to penetrate the paramagnetic materials. Okay, in this do not tends to penetrate the paramagnetic material. In paramagnetic material, it tends to penetrate the paramagnetic material. Okay. What is ferromagnetic material? Same. The magnetic lines of forces is applied. The magnetic field tends to the magnetic fields tends to strongly penetrate the ferromagnetic material. Okay. Next, in diamagnetic material, non-uniform magnetic field, diamagnetic material move from strong to weaker. Okay, strong to weaker to repulsion. Okay, to repulsion. Okay, in what is in paramagnetic? In paramagnetic, non-uniform magnetic field move from weaker to stronger field with weak attraction. Okay, in this it is a weak attraction. Okay, not strong, very weak attraction. In ferro case, non-uniform magnetic field. Diamagnetic materials in this tends to in this non-uniform magnetic field, ferromaterials move from weaker to stronger attraction. Okay, in this weaker to stronger attraction, moves from weaker to stronger attraction. Okay, next. Next one in this. The main is this substitutability. We discuss about substitutability in this. What is in this diamagnetic? The substitutability is equal to negative. Okay, the substitutability is negative. What is in case of paramagnetic? The substitutability is positive and small. Okay, positive and small. In case of ferromagnetic, the substitutability is positive. Okay, in this small, in this same positive, but in this the substitutability is positive but large. Okay, the substitutability is large. Okay, the substitutability is larger than 1. Okay, that means substitutability is larger than 1 is larger than 1. The substitutability is. Okay. Another example I will tell. For example, if the north and south pole are kept very closer. Okay, north and south pole are kept in very closer. In case of paramagnetic, I am telling, place two magnetic fields kept in closer, so near. Okay, north and south so near. Okay, so closer. Then the lines of magnetic fields are strong in this. Okay, lines of magnetic fields are strong. Then in this, what happened? What happened in this? Lines of magnetic stronger. Then lines of magnetic stronger. Then hip. These are hip. Okay, hipper form. In between some center. In center hipper form. Okay, north or south. Some hipper form. Okay. Some hipper form. North or south. North and south are very closer it is. Then what happened in this? Then the hip-performance center, not at the poles, magnetic poles. The line of magnetic two ball in these two balls, the amount of magnetic field made make hip at center. Okay, make hip at center. In case of northern pole are very in this closer hip-performance center, and if northern pole are there is a long gap in between them. Okay. Then what happened? The hip will be formed at if north and south pole is there. Okay. Then hip are formed at poles, not at center. If it is closer, then hip are formed at center. If it is far, north and south pole are far, so far, and due to magnetic the hips are formed at poles, two poles. Okay, hips are made at two poles. Okay. So this in case of diamagnetic, this is just opposite. This is opposite, just opposite. What is if north and south pole are closer? In this case, the perform at center. Okay, it perform at center. If north and south pole are far away. Okay, far away. Then where the gap is there, north and south, the gap is there. Then what happened? The hip will be formed at okay. See, in this what happened in diamagnetic, quite opposite in this. If north and south pole are sorry, quite opposite in this. If the north and south pole are far, then it will form at center. If north and south pole are closer, then it will form at poles. This. So in this poles gap is due to poles gap, very gap. Poles are far gap. They perform at center line. Magnetic field is less in center. Magnetic field is less. Okay. If poles are closer, if magnetic poles are closer, it forms at pole. In case of diamagnetic, and in case of paramagnetic, what is there? If magnetic field are poles are closer, it will form at center. If poles are far away, it will form at poles. In case of these poles are far away, if in case of diamagnetic, poles are far away, it form at center. If poles are closer, it will form at poles. Okay, it will form at poles. It is closer. North and south poles closer, then it will form at near poles. Okay. It will form at poles. Due to analysis of poles. Okay. These diamagnetic, because of this magnetic field, tendency towards a shift at less magnetic field. Okay. The magnetic lines of forces push. Okay. In this magnetic lines of push do not pass through it. So the difference, due to this difference of dia, so we discuss about these differences, next classifications, all we discuss briefly. Okay, about diamagnetic, paramagnetic, ferromagnetic, and examples also for dia is water, alcohol, mercury. Paramagnetic, aluminium, lithium, chromium. Ferromagnetic is iron, cobalt, nickel. Okay. Very easy topic we discussed in briefly. Okay, once you study, and tomorrow I will ask you questions. Okay.